Hello, everyone, and welcome to today's presentation on managing the data risk of generative AI. We are super excited to dive into this very timely topic with you today, as you could heard earlier. In particular, I'm excited to introduce you to our speakers. Joining us are Ian Coe, the CEO and a co-founder of Tonic AI, who has been at the helm of Tonic since the very start, and Anders Steele, our head of AI, who joined very early on to lead our AI team. Before we jump into their presentation, we would like you to know that we welcome your questions at any time. We love questions. So feel free to drop them in the Q&A or in the chat if there's something you'd like to hear more about, even as they're speaking, and I'll make sure we get to them. We'll also leave time for questions at the end as well. All right, with that, I will pass things over to Ian.
Thanks, Kara. Hey, as Kara mentioned, I'm Ian Coe, CEO and co-founder of Tonic AI. I'm joined here with my colleague, Anders Steele, our head of artificial intelligence. So today we're going to be talking about some of the risks involved in deploying generative AI and how to mitigate them. In this talk, we'll cover the pragmatic realities around the need for training data to make progress, the risk it poses, and most importantly, how you can deploy generative AI in a safe and secure manner.
Ian?
A lot of the mitigation.
Oh, just jumping in, could you share your slides? Thanks. Perfect.
All right. Well, now you know who we are. And yeah, this is what we're going to be talking about. So, as I mentioned, a lot of the mitigations we'll talk about will even leverage none other than our friend generative AI. So, just to give you a little bit more context on who we are, as Kara mentioned, we work for Tonic AI. Tonic AI is a synthetic data company, and we like to think we've been doing generative AI since before it was cool. We founded Tonic because we were frustrated that we kept seeing enterprise data could either be useful and insecure or secure and hard to use. Our goal was to build a platform that made it easy to deploy synthetic data to reduce that trade-off for all our customers. Today, we have hundreds of customers across industries using our synthetic data to serve their development and data science teams. They get all the value of production data without actually having to copy sensitive data around their organization. By giving them high quality data, we see teams author fewer defects, ship faster, and have a much stronger security posture as an organization. There are two primary paths in our product, one built for developers in need of de-identified production data, and the other built for AI team or ML teams looking to utilize to augment their data for model training and analysis.
Ian, sorry to jump in again. We're seeing an odd cutoff on your slides. I'm wondering if you could reshare. Oh, there we go. That might be it. Could you click back one slide just to make sure that we've got the full slide now? Yep. Okay. Perfect. Thank you.
All right. That's all right. Generative AI is really taking off, but slide presentation still 1990s technology. So we're going to take it for granted that you're interested in deploying generative AI if you're here. In the past, just to sort of motivate this a little bit further, in the past 3 weeks, we've had people turn sketches into website, promise to replace lawyers. I'm actually kind of excited about that. Joking, my brother is a lawyer. Cook food, make movies, write complex code, and of course make games like Pong. Many of these were unthinkable even a few months ago. So, in 10 seconds, what is generative AI? Generative AI is training data fed into a model that learns and often has feedback that improves upon its initial training. The current model architecture most popularly used for training generative AI models for NLP style problems, which we're going to be kind of the focus of what we're talking about today, is transformers. It's a neural network that can not only learn from patterns of language, but also context in space. For this talk, we're going to spend a lot of time talking about the training data, since that's where many of the enterprise data challenges arise. As you might imagine, this only gets more complicated as you start needing to feed it proprietary data to learn about more specific use cases. So why did this space go from 0 to 60 in about 1 second? Scale is a really big part of the answer. To get a sense of the size, the entirety of Wikipedia is about 3 billion tokens. That's roughly 1% of the training data used for GPT-3, which is not the latest model anymore. The costs, aren't publicly disclosed, but you can estimate. VentureBeat recently estimated it cost $12 million to train GPT-3. Some have claimed it cost hundreds of millions of dollars when you consider the ancillary costs of data aggregation and other things. Interestingly, the costs of improvements to these models are likely to be orders of magnitude less expensive than kind of getting 0 to 1 here, for reasons we'll cover later in the talk. There are essentially 3 variables that predict model accuracy: the amount of computational resources, the size of the model, and the size of the training data. As you can see from this chart from OpenAI, these variables do it with a surprising degree of precision. There are really 2 remarkable things about this chart. The first is how accurately these predictions match the empirical observations. And the second is that the diminishing returns in the asymptotic shape of the curve, which suggests that you're going to get less and less over time, which really leads to this idea that, you can predict model accuracy, and we can plot the expected performance of models when we know the core inputs. So given a fixed compute budget, this plot shows the predicted model performance as a function of model size and data size. The best performing of these models is Google's PaLM, followed by a model called Chinchilla. What's really noteworthy is that Chinchilla is a model that's less than half the size of GPT-3, trained on a data set that is over 4 times as large, and it performs significantly better. So that really underscores the importance of data over, just increasing model complexity. The shape of these curves of these regions show us that data is likely to, in the future, continue to yield a bigger return for our model as well. So, really, you can kind of think of these as scaling laws. And basically, these scaling laws say that data, not model size, is the future and the current bottleneck for improvement in most cases. You could say this a little differently and kind of think of it, more conceptually as adding intelligence or more parameters to the model has really diminishing marginal returns, and we're already maxed out there for the most part. So really, more examples, more training data is likely to be the future. So this means that, since data is the new gold, you can expect your machine learning teams to come to you looking something like that AI generated character over there, the yellow guy on the left there. And basically they're going to be data hungry as they look to compete with other teams, other organizations. Unfortunately, granting unfettered access to this hungry database has some substantial risks. Aggregating all that data for training often requires moving to less secure environments, increasing the risk of a breach. The other big risk that we'll also get into is as the models get more complicated, there's an increased risk that they memorize data and essentially cause a breach via the model. And then the last challenge is that your team may send data to third parties with very different data policies than your organization and unintentionally share confidential information in breach of regulations that your organization wants to adhere to. For example, data submitted to OpenAI from 2020 through March 2023 was potentially used in training data for models like ChatGPT.
Ian, I'm going to jump in with a quick question from the audience around making these models more robust. The question is, can the adversarial robustness of generative AI be augmented using reinforcement learning? Until we know more about how humans think, I believe this question will remain unanswered. Thoughts from the speakers? Asking in part because because Tonic AI is a synthetic data company. Yeah.
Yeah, I can jump in there a little bit. I mean, right. Reinforcement learning on human feedback is exactly the strategy for aligning these models, making them, I guess, the outputs a little more robust and truthful and helpful, and that indeed uses reinforcement learning in an essential way to essentially guide the model towards good outputs. I mean, I think towards your question, this is still an active area of research, and how we continue to improve these models and align them and make them more truthful, less prone to hallucination, more helpful. I think that's ongoing work.
Thank you, Andrew.
So I want to get a little bit into what actually a data leak looks like. In a simple case, it means that you prompt the model and get something sensitive from the training data set. GPT-2 can be prompted to return actual addresses, which we've shown in a redacted state here on this slide. Similarly, Stable Diffusion can be prompted to return a real person. The risk that this happens is primarily proportional to the size of the model and the number of times the example appears in the training data. I wish I could say this is all theoretical, but we actually are already seeing this in the courts. So GitHub is being sued for how it used data to develop Copilot. And central to this lawsuit is the fact that Copilot, when properly prompted, will output perfect copies of copyrighted code. And additionally, Stability AI is being sued by Getty Images for using copyrighted images as training data. And part of that, part of the challenge, that part of where it gets uncomfortable is that Stable Diffusion will sometimes generate images with the Getty watermark. And these are models trained on data in the public domain. This certainly won't get better or more challenging to manage as companies train on more sensitive and proprietary data to hit more use cases. Fortunately, there is a light at the end of the tunnel, and I'll turn it over to Andrew to talk about some of the mitigations and ways to make this better.
All right. Thanks, Ian. Yeah, so the good news is it's not hopeless. There are relatively easy steps that you can take today. One, you can deploy on-prem. We expect that most of the major cloud providers will offer ways to deploy large third-party models in your VPC. Or alternatively, you could deploy smaller fine-tuned models instead. Another thing you can do is redact PII from the data used internally, and especially if you're going to send it to third parties for inference or fine-tuning. And finally, if you're going to be fine-tuning these models, you should consider using differential privacy, especially if this is going to be fine-tuned on any potentially sensitive data. All right, so speaking to this first point of deploying on-prem, one of the consequences of the fact that data is a bottleneck is that smaller models may perform comparably to huge models like GPT-3. For example, researchers at Meta have recently released a series of language models called Llama, which are competitive with earlier versions of GPT-3 across a wide range of tasks. They are trained on larger amounts of data but have fewer parameters and thus are much cheaper to train. Along these lines, Bloomberg recently announced Bloomberg GPT, a 50 billion parameter model trained on a combination of text sources and financial data. This was trained on commodity hardware and AWS and using standard software for a fraction of the cost of training GPT-3. So this means that there are options for training on-prem. Training costs are dropping as hardware improves, and the techniques for training these models are becoming more widely known. And in addition, now there are a variety of open source models that can be used as starting points to fine-tune these task-specific models. Now, Meta's models, the Llama models, are not available for commercial use. And those models with permissive licenses are not quite there in terms of quality, but they're getting closer. In fact, a group has just announced plans to release an Apache 2.0 version of the Llama models, starting with a release a couple of days ago of compiled training data following Meta's recipe. Now, instead of training or fine-tuning your own foundation model, of course, it's also possible to deploy third models like GPT-3, GPT-4 on your private VPC, at least if you're an Azure customer. And if you're a GCP customer, then, well, Bard is coming on GCP and potentially other models as well. Okay, so now the other thing to do when either fine-tuning or sending data to third parties is to redact PII. from your data. So tokenization and redaction are solid for things like PCI compliance, but they're a bit challenging for training models. Like this is kind of difficult to do because what happens when the data itself has business secrets? Like, do you want ChatGPT to know that you're going to beat or miss next quarter? And so while there's no foolproof way to redact contextually sensitive information, at the very least, it's possible to redact PII such as names, addresses, and so forth. So now an additional layer and a more robust privacy preserving technology is differential privacy. And to kind of give you a very quick summary of what this is, with differential privacy, you're adding carefully calibrated noise to a data process in a way that obscures an individual data point's footprint on the process, but preserves useful aggregates about the data. So generally speaking, the more noise you add, the more protection, but the less useful information can be drawn from the data. There's this privacy utility trade-off here. Now, for example, it's possible to add differential privacy to the training of ML models, for example, fine-tuning your large language models. And this provides you formal guarantees of privacy, but there are downsides here as well. In particular, there's increased costs and training overhead. And these formal guarantees of privacy may not necessarily align with intuitive expectations. In short, like this is an active but promising area of research. Okay, so now to turn to a more optimistic beat, let's talk about some of the applications of generative AI to privacy, which is something that we're passionate about. And we see at least three key ways, which I'll just call synthetic data, auto detection of data, and fine-tuning with synthetic data. Now, language models are not the only thing in generative AI. There have been a multitude of breakthroughs recently, and now generative AI can be used to create synthetic tabular data sets which preserve the statistics and structure of real data while also preserving the privacy of individuals in the data. These synthetic tabular data sets can be used for analytics, they can be used for training ML models, and these models will produce comparable results to models trained on production data. And what's more, once you have these synthetic data models, you can now programmatically adjust this data to account for biases and imbalances in your data set. This allows you to even improve model results compared to training on just imbalanced production data. In fact, we have an offering here. Our data science offering makes it easy to synthesize tabular data sets. You simply connect to your data, you can define a view of the data you need, and you go ahead and train a generative model. Once you have that generative model trained, you can synthesize the data where you want. You can export a CSV, or you can access it via Python SDK. And by accessing it via SDK, you can control for those things like the class imbalances or adjust the biases in your data set. Now, the other thing that's a really exciting application of generative AI is improving PII redaction. And this one's particularly fun for us because it's literally transformed since we first started talking to customers. Like in sales calls, when customers would ask about PII detection, we would usually say something along the lines of, the best models were around 90% accurate in PII detection, but contextual detection was nearly impossible. And we give the example of a sentence like, the president tested positive for COVID on Saturday. So at that time, the models here would be able to identify Saturday morning as a time and Kevin O'Connor as a named entity, but would miss the key, contextual entity that this was talking about, namely the president. Now, of course, all that has changed. Even a non-fine-tuned ChatGPT model does extremely well here at finding and redacting all PII. All right, now finally, one of the other things that we're really excited about in the generative AI space, and I think we'll see increasingly, is using huge general purpose models to generate training data for smaller task-specific models. And a very recent example comes out of a group from Stanford, which used Meta's Llama models and synthetic data generated by GPT-3 to train a chat GPT-like model for cost of $700. To train this model, they needed a large number of instructions and examples. They're using a strategy similar to the reinforcement learning on human feedback strategy. Now, they start with a small set of 175 seed tasks and example outputs. For example, one task would be give me a quote from a famous person, and the output would be, ask not what you can do for what your country can do for you, but what you can do for your country. So they take those seed tasks and then they ask GPT-3 to generate 52,000 more examples. And they do this for a very small cost. It's, several $100s. Finally, taking that much larger data set, they fine-tune Llama on these synthetic examples for another few $100s, resulting in an impressive chatbot trained for very little money.
Andrew, I'm going to jump in with a quick question.
Yeah.
It would be helpful to hop back a few slides. The question is, what is the level of positive productivity value of use for the synthetic data that we have created?
What is the level? How to interpret that question? In terms of like the productivity positive use, like one of the exciting applications here is unblocking your data science teams, getting them access to the data faster than they could originally get access, largely because of internal regulations and red tape around sensitive, detailed customer data. So this like rapidly decreases the iteration time for model development. And in terms of like what is the kind of quality of these models, basically models trained on synthetic data are going to perform somewhat worse than models trained on real data, but comparably. Like, to kind of give you an example off the top of my head, I think like a lot of the case studies that we've seen here have, for example, classification scores measured by ROC, AUC dropping maybe a few percent, but still kind of in the same ballpark. Now, what's also interesting about these models is that if you look at the downstream models trained on synthetic data, and you look at things like feature importance, the stories here in synthetic data are going to be very similar to the stories in real data. So in summary, what this tells you is that you can do your model prototyping and your iterating very quickly on synthetic data. You get similar classification performance or regression performance. You get similar levels of feature importance. So you can get an understanding of the data even before you have access to it. But at the end of the day, you probably still want to train on real data if you're eventually going to have access to that. And if you can't, well, this is an alternative.
And I think there's a follow-up question here. Is there a way to determine the quality of the responses, basically data QA processes that could be used? Which is that speaking to these charts that you're showing here?
Yeah, so like there's for the synthetic tabulated data, kind of assessing quality here is a little more straightforward than assessing quality of textual data. Like in particular, you can look at things like on the right, we have these univariate distributions where we see the synthetic data matches extremely well the distribution over time of the real data. Here, this is like an example of synthetic like financial transactions. And so when they occur over time is an important dimension of that data. And then on the left, we have things like, measuring the privacy of this data using this distance to closest record. I won't speak too much about that, but, in addition to, kind of comparing distances between marginals, then there are other types of things you can do, which is, along the lines of the ML utility evaluation, where you train simple models to predict, one column from the remaining columns. And you do this across, various pairs, and you compare the performance in the real data of those models to the models trained on synthetic data. And so this is a way of kind of analyzing the structure of the synthetic data, making sure it's telling you the same stories. And so these are kind of some of the techniques for evaluating that. Whereas evaluating textual data is, of course, much more challenging, given that you can express anything in text.
I'm also going to put a link to our latest blog post that talks a little bit about data validation and building ML model training.
Excellent. Cool. Right. So let me close with some takeaways. And of course, we asked ChatGPT to summarize our talk. And we hope that makes it into the training data. So we'd summarize, this as follows. First, the rapid rise of generative AI brings opportunities, but also data risks. Two, you can mitigate these risks with on-prem models, redacting PII, and leveraging techniques like differential privacy. And then three, at the same time, while there are risks, synthetic data and other capabilities of generative AI are a game changer for data security. With that, I'll turn it back to you, Kira.
Oh, okay. I'm just looking at these other questions coming in, and there's some great ones that I actually haven't heard before. So first one for you, are there any types of data that synthetic data would not apply or be efficient for example, GPS data?
Oh, that's an interesting question. I mean, I think it depends very much on exactly the type of problem you're solving. But GPS data, potentially, is an example of structured tabular data where our techniques work well. I think a few years ago I would have said synthesizing good textual data would be hard, but now we know that that's possible. I mean, you may need very large models to do it, but it's a solved problem in some sense. And we also see exciting developments in terms of synthetic image data. There's a recent paper out of, I think, Google Research showing that synthetic image data generated by diffusion models can be used to augment basically image classifiers like ImageNet and improve model performance. So I think, basically in all of these areas, like structured data, image data, textual data, there's been a lot of really exciting advances, and that will continue. But of course, I'm sure you could come up with an example where it's very hard.
Yeah, that's true. There's a follow-up here. For the GPS data use case, take an example such as running regression tests for a feature related to a data set of runners' Strava GPS info.
Yeah, no, that's a really good, interesting example. And I think I will say GPS data here is challenging, in terms of structured data. This is, I don't want to undermine the complexity of this. But I also think there are techniques here where, essentially, if you're trying to understand the aggregates of running paths, knowing where, what are the popular paths, that seems completely feasible. And I've seen case studies along these lines. And this is an exciting application of this synthetic data because you don't necessarily want to know where everyone is living, or what they start their run at home and they end up at a coffee shop. Knowing that I like a particular coffee shop is not the point of this data.
Or knowing where you live as well.
Yeah, or knowing where I live. Yeah,
and at what times you leave the house and at what times. Yeah, all that.
Right.
Lots of other questions here. Have some of these synthetic data approaches made e.g. for tabular, the Stanford Llama synthetic data samples, made their way to Hugging Face or open source?
Yeah. I mean, there are some very cool open source, open source tabular. I'll go through each of these examples. So for synthesizing tabular data sets, there's the Synthetic Data Vault project, which is open source, and that has some wonderful techniques. There's a lot of model kind of definitions and infrastructure on Hugging Face. For example, there's code for executing the Llama models as Hugging Face in Hugging Face, but getting the actual weights, of course, depends on sending a request to Meta and having that request approved. I think all of that is going to be changing in a more open direction soon. I mean, obviously these weights have been leaked, and so a lot of people have access to these. And there, as I mentioned, there are other organizations. I think Together XYZ is the organization that announced their plans to release an Apache 2.0 version of the Llama models, and those will inevitably be something that you could just download on Hugging Face. Stable Diffusion is another example where you can get the weights on Hugging Face. So to kind of add on to your question, I think now is a fantastic time to be in AI and ML engineering, because it's so easy to get started with hacking on these models, thanks to things like Hugging Face and other like excellent open source initiatives.
Thinking of the chart that you showed early on, that rocket ship just going up, up, up. I'm wondering, like, when is it going to hit the flat? When is it going to, I don't know, go into parking orbit and just kind of coasting, as opposed to just continuing to climb? All right, another question that I've also not seen before: is there a risk that criminal activity can use synthetic data to acquire personal or business data, and how can we combat that?
I mean, this is already happening, right? There's like someone who used text to voice to synthesize a voice recording of someone's family member faking a kidnapping for a ransom. Like, I mean, this is one of the scary examples of how these things can be abused. Similarly, like having access to like very good text synthesizers opens the possibility for all sorts of, I don't know, like really sophisticated spear phishing campaigns at scale. So, these are real issues. I'm not sure what sort of mitigations we have against these things, given that a lot of this is actually already in the open. I mean, like I said, the llama weights are floating around on BitTorrent. So, there are tools and like techniques addressed at, for example, detecting synthetic data. Like, has this text been written by GPT? I don't know how tractable these problems are. So I think part of it is just building an awareness of what is possible and like becoming aware of the threats that are now like practical. So
yeah, my takeaway is don't tell your life story to ChatGPT, because then you don't know who's that,
Yeah, exactly.
Identity theft at the next level. All right, another question here. I imagine medical images such as pathology, high resolution, and radiology, 3D multimodal, will still be challenging as a generative AI task without breaking the problem into smaller tasks.
Yeah, I completely agree with that. That's a good example of a really hard problem. I think like one of the limitations there, in contrast to like text models or less domain specific image models, is that the amount of data that you have to build your generative models is comparably very small. And so, as we've been saying, like the more data you have, the better these things work. In contexts where you don't have as much data, then imbuing your model with some sort of inductive bias or breaking the model into smaller problems, as you suggest, is definitely like perhaps is a viable strategy, maybe not the only one. But yeah, I definitely agree with that. Like in these kind of more domain specific contexts, these things are hard, and particularly in high risk applications like medical imaging. That's another dimension in which these things are hard, because the threshold for making good data for medical applications is so much higher than making good, marketing copy.
Yeah, that's a very fair comparison. All right, along the lines of the criminal activity question, are there any guardrails that you would recommend organizations put in place around their employees' use of tools like ChatGPT? And that's a question for either Andrew or Ian.
Ian, do you want to start, or do you want me?
If you have thoughts, go ahead, and I can also. So, I mean, should we have guardrails? I mean, I think yes. Like, obviously, and we're already doing that to some degree, right? I think there was kind of a rush, as there always is, to kind of get things out that are really cool and really powerful. And now we're seeing folks figure out ways to still enable folks to be productive, but have a little bit more control over what happens. So OpenAI even has a form you can submit that allows you to not include any of your if you want to submit your life story, you can ask them not to include it in training data. So there's things like that. As Ander mentioned, there's going to be a lot of on-prem options coming really, really soon, or already out there. So I think the guardrails will come. I still, I think my thought is that there's going to need to be a set of tools that helps people do this so that it's not too hard. Otherwise, there's going to be a lot of mistakes. I mean, as we already saw with some really sophisticated, smart folks, you have the challenges like around, Copilot and getting images. So I think if the tools aren't there to make this really easy to protect yourself, people are going to make a lot of mistakes because they're, it's just too valuable to not have something. And then so people are going to push the envelope if there aren't easy ways to protect yourself.
Yeah, that makes sense. All right. Question that just came through. What tools do we have to detect, if data was synthetically generated? I think, Andrew, you were speaking about that a little bit earlier.
Yeah, that's a cool question. And there are a few approaches that I'm aware of. One, I mean, essentially you can just look at data generated by, you can look at a particular text sample and you could ask, by feeding it through, for example, GPT-3, ask how likely each word is according to GPT-3. Perplexity is one of the measures of this. And so things that are extremely likely according to the model they may either be part of the training data or they may be something that was synthesized by the model. Now, this is obviously easy to game is the thing, like by simply perturbing the output, like maybe replacing a word here or there, you can, dramatically change kind of the perplexity of these things. So it's a very brittle method. Similarly, there's, techniques that people are investigating for like watermarking generated text data. Again, fairly brittle, but like, I guess the answer is there are some initial tools here, but maybe it's just an extremely challenging problem.
I really like this comment that just came through. The audience member saying, just like there would never be enough policemen to guard a society that is largely prone to criminal activity, the same could be said of technology as it becomes more capable. If we do not prioritize ethical behavior in all of our approaches, trying to protect ourselves would become more and more challenging. It's so true. And honestly, it like kind of reminds me of the very reason for which Tonic was created. We wanted to enable more ethical processes in the data that developers are using to build and test their products with. So that's a true statement. And that actually leads me to another question that I do see here. What are the use cases that Tonic currently focuses on with our generative AI products?
Yeah, so we're fairly focused on the context of tabular data at the moment. So as I mentioned, we have an offering there for synthesizing rich tabular data sets or views of databases or these kind of structured data, which is necessary for developers or data scientists. But we have some other stuff forthcoming.
Yep, there was something new coming up. Was there anything you want to add as well to that comment? I didn't want to jump over it too quickly.
What was that?
Oh, the last comment that I shared from the audience member.
Oh no, I mean I agree completely.
Yeah. All right.
Yeah.
Oh, go ahead.
Yeah, I guess what I would say is that again, just sort of to harp on sort of a central thesis of Tonic and my sort of personal belief on these is that it's hard to get people to act ethically it's hard for them to act ethically and get what they want. So the more we can bring to make it easy to get what you want and act ethically, the more there's sort of, I think, a small activation energy people are willing to expend to get to both ethical and productive behavior. And I think the more we can do to bring that down, the more, the better off we're all going to be. And so I think pushing really hard up front will hopefully get us there. And, the sort of earlier interventions, so they can become sort of the habits that we use when we're doing this type of work, we'll all be in a much better state. So easier and sooner is always better.
Yeah. Along the lines of that comment, there's a question here. Do we have any insight into how database companies, old and new, SQL, NoSQL, structured, semi-structured, unstructured, are viewing generative AI synthetic data?
So certainly, I think there is an opportunity. My sense is most of the opportunities there are on the end user side. So in the sense, like, there's a pretty obvious one for BI, for example, right? Like, if you want to ask a question of your database, you need to write SQL and then plot, get like a data frame out and then plot that and do all those things? Or can you ask a relatively intelligent bot, hey, what is the trend of my subscriptions over the past 4 quarters, and get just get a plot, and not have to think about the structure of your data, not have to think about what the chart should look like. All those things, I think, are super achievable in the very near term. So my sense is that database companies are likely to be thinking about what happens when bots start writing queries against my data. And then obviously a lot of the tools that people currently use to understand, to optimize, all those things are probably thinking, oh, AI is likely to take over a lot of these use cases. And the same thing would go for data catalogs, observability. All of those things are like, there's a lot of opportunities for AI to make that easier.
I have that's kind of making me think of another question that I wanted to ask you both, that I think, is an interesting, another way of looking at generating synthetic data. For structured data in particular, what are the challenges or drawbacks to feeding generative AI a prompt for what, your desired output data should look like, rather than feeding it the real world data if we want to, maximize our privacy?
Right. Yeah, that's a fun question, because it depends like what you want to do with this data. Like, if you just need a sample of data to test your application against, you don't really care so much about maybe the relationships in the data, in your existing data. Maybe you're more interested in the kind of structure and constraints of that data. And there, prompting an LLM is definitely a possibility. But if you're trying to develop insights from your data, there's no way that you're going to be able to prompt an LLM to give you synthetic data which will have the same insights. Well, you could give it your data and ask it to synthesize more, but there we come into all the privacy risks that we mentioned earlier. So I think in terms of building synthetic data that contains the same types of insights as your existing data, but is more safe, there are like more tailored approaches, as we mentioned, are kind of the way to go.
Awesome. Thank you. I don't see any other open questions. If you do have a question, we're coming up on the top of the hour. So please get your questions. Okay, here we are. One more question. And that's okay. That's okay. You can go ahead to the Let's Chat. That's perfect. This actually is a question that that feels appropriate for the Let's Chat slide. Are we open to partnerships?
In general, yes, of course. I think, as I mentioned, we believe this is really important, and we want to get things out there in the highest quality way as quickly as possible. So broadly, yes. I mean, obviously, would have to talk about the specifics, but yes, we're happy to chat. Please reach out. This is obviously a keen area of interest for us.
Yeah. Excellent. If there are no other questions, I think we can close things out. This has been such an awesome conversation. A thank you from the audience for such critically important subject and a great group handling meeting. Thank you to the audience for these comments and all your questions. Really awesome. If you do want to reach out, please, you can contact us by hello@tonic.ai. You can visit our website if you'd like to learn more about what we're doing in the generative AI space. You can also get a free trial of Tonic. If you go to app.tonic.ai, you can sign up, create your own account. We'd love to hear what you think about it. We've got tons of blog articles on all of these topics. We've got other webinars. You can access the recordings of ebooks. Thank you all for joining us. Thank you so much to our speakers. This was fantastic. Really answered a lot of questions here today. Really appreciate it.
Thank you.
Thanks, everyone.